Hello, and welcome to the Commercial Network Services Lifecycle Management, Year Automation, that's a mouthful, webinar. This is the fifth in a series of TOSCA implementation briefings. All of the briefings are available on our YouTube channel, and they are in a library following our webinar today. I will send a link to the library so you can view all of them. They are fantastic, and I know that this is going to be a really great one too. We will be recording this, obviously. We all got that notice. We're going to have a Q&A at the end. If they come up for you during the webinar, but we are going to hold them to the end. Okay, so I already got a question about YouTube. Yes, we are. Okay, so we have two presenters today. Our first presenter is Gaurav Kanpur. He is the director, and our second presenter is Patabi Ayasami. He is the principal engineer at Comcast Silicon Valley Innovation Center. In closing our webinar today, Chris Lowers will say a few words. He is the chair of the OASIS TOSCA Technical of Ubicity. And with that, I would like to turn it over to Gaurav. Thank you.
Hi, can you hear me okay?
Yes, perfect.
Thank you. Thank you all for joining today. My name is Gaurav Kanpur, and I lead software development projects in the engineering group at Comcast. Also joining with me today is Patabi Ayasami, who is our technical lead, and he drives architecture and orchestration for our NFV project initiatives. Comcast is one of the leading US service providers for communications, entertainment. So in today's tech talk, I'm going to start by sharing our journey, how we got to orchestration with TOSCA and building a platform, and then also share our overview of our platform architecture. And then Patabi is going to pick up on security to talk through how we got to modeling and using TOSCA. And then we will conclude with some of the challenges along the way and the problems that we are solving, followed by Q&A. Sharing the journey, how we got to embark on TOSCA and leveraging it. Early on, prior to the virtualization, older days, your customers always had a demand for more than just basic connectivity. Example of some of the application and service, data encryption, NAT, traffic steering, quality of service for the specific applications like voice application and so forth. These were offered through various vendor products and were actually requiring physical hardware. This was position required truck rolls and upgrades happening on customer sites. So it was a fairly slow process, and with virtualization coming in, definitely helped us in consolidating, going a lot into the commodity in order to run these PNFs. Definitely helped in faster delivery and was a cost-effective way. This also allowed us to look at solutions which allowed us to run VNFs purely in the cloud and applications. As an example, like usage-based billing, or completely doing DNS from the cloud and so forth. However, the solutions are still fairly complex, and there were a lot of challenges, though we had made them cost-effective and were able to expedite from the complete physical CPE and paradigm. There were challenges regarding coordinations with the technical operations, a lot of methods and procedures with the OSS systems integration challenges. A lot of the permutation combinations required where OSS would have to feed in the configurations that were required in order for us to provision and activate the services that for these customers in the network. Imperative programming, if for those who understand imperative versus declarative, you are essentially focusing on the how and trying to achieve this provisioning and activation that's happening in the network. There wasn't really a service definition on services. And that was pretty evident in what was challenging in our software. It was fairly complex, implementing all the permutation combinations in a completely imperative way. Challenging to add new vendors for the same type of service and offer a portfolio to the end customer. So in order to solve that complexity, we set some goals, and these goals would then become and defining what are the changes we need to do in our platform architecture. The goals are listed, but I will broadly categorize into 4 key areas that we have. Consistency. So we wanted to have common APIs for all the DNFs and for different DNF vendors, but have a consistency in the APIs that are offered by one common platform that was responsible for orchestrating the different services. Next was agility. It was very important that we quickly into the platform and build that catalog of services that the customers can pick and essentially manage their changes that were happening behind the scene on the VNFs as their softwares would evolve. Many a time, these were backward incompatible changes so in the platform. Next was reliability. We wanted to reduce the overall errors and have a cookie cutter approach that was tested and have predictability of how long it's going to take to provision this services, which means multiple things. We wanted to have essentially an inventory of what was provisioned in the network, what was available, and what were the resources, and have this view as a catalog. And also keeping the network as source of truth a bit more in the later slides. So with these goals in mind, we started to look at orchestration and evaluate the reference architectures for the services that we could model and essentially model them in a vendor agnostic way for different domains and for also different environments, which would span across physical, multi-cloud, on-prem, and with VNFs. We started to look at ONAP as one of the reference architectures that were available. And we started to build out a platform overview, or primarily the functional components that we really listed out here. By the way, ONAP stands for the Open Network Automation Platform from the Linux Foundation. It's a networking project. So in this overview, let me. So the north of this is where we have our client customers platforms such as OSS, BSS systems, portals, and so forth, which interact with the APIs that our platform offers. I'm going to get into what are the type of APIs we in this architecture. Then we have certain components which we leverage from ONAP. These are all these are not open source. These are morphed version of them through our partnerships with other vendors. We have the STC, which from ONAP, which is the service design. And this is essentially where the life cycle of TOSCA begins for us. where designers are using the SDC to create and model services for the different use cases that our platform needs to support, and essentially distribute those Caesars into whereon these Caesars are essentially distributed into the service orchestrators and into the inventory. The inventory is the ANAI, again, influenced by what we have in ONAP. And ANAI refers to the active and available. So that's the part where the models are distributed into the various components. These are functional blocks, but within the platform, the actual deployment is a collection of various microservices that are running on a Kubernetes environment. Then we have another interesting layer I'm going to talk about is the service composition and the activator. The policies and rules is essentially an engine which we leverage when at runtime when and a plan is built out for, excuse me. Sorry. Yeah, a plan is getting built out for how do you orchestrate the service and perform the operations. You have to work on closed loop use cases that the platform supports. We leverage the policy and the rules engine as part of that. The configurations, when we were doing orchestration prior to TOSCA were all we still continue to support YANG, and while we are modeling the services in TOSCA. So essentially the validations of those configurations which are modeled by YANG also happens as part of the platform. Is where we do the integrations with specific controllers or DNF managers. And that's the meat of the business logic of how do you provision and activate against different vendor products. There could also be other orchestrators plugged in on the southbound. This is a north-south. If you look at where northbound is where we have the abstracted APIs for OSS systems to interact with, and on the southbound layer is where we have this plugins which entail the business logic for provisioning operations onto the target systems such as VNFs or other cloud platforms. Okay, so I'm going to zoom in a bit on the service composer and activator, and what role does that play into our platform. The client apps essentially interact with this layer, and this layer helps us abstract. It's another layer of interaction, which encapsulates the interaction. We have a concept which we call as DSLs, domain-specific language, that we have built in order to define the features that are essentially as part of the network service that the customers are want to avail, and there are implementations for this DSLs, and those implementations are which drive the interaction with the orchestration, and essentially also do a mapping of what are the inputs that are going to be driven off from the OSS systems, and performing and picking which route to take based on the service that you want to orchestrate on. It also gives us the flexibility to integrate with other systems which may not be orchestrated through TOSCA, another option, but that is all driven off with this concept of adapters that would drive what the DSL's implementation would be. I'm going to get into some of the details about the type of APIs and from the which are essentially from the TMF leveraging in order to standardize on the northbound interfaces. So the nature of APIs that this layer offers are essentially onboarding this struct, the DSLs, which is a collection of the features, onboard them, associate the required implementation, which is backed by TOSCA, and provide the mappings and the validations that are to be performed once outbound layers. These APIs are primarily async in nature, and for the OSS systems to interact with and essentially offer capabilities to register for callbacks, back to learn about running downstream in our platform. These callbacks are RESTful in nature, but we also support other means through events and streams, such as, as an example, with Kinesis. So you could have an asynchronous communication going on between northbound OSS platform. Coming to the APIs that the layer, the activation and composer layer that you saw, the type of APIs we are TMF 640 specifically for the activation and configuration APIs. For doing the order management specifically, we use TMF 641, which essentially performs the operation of the service lifecycle. I mentioned about SDC, which is the catalog, and we have used TMF 633 as the catalog management APIs in order to look at what are the different Caesars, model IDs for them, and so forth. Then for the resource management, I mentioned about the TMF 639, which acts as a wrapper on looking at what were the resources that once they are available after activation, and what is the resources from also available for orchestration needs. Those are managed and available. So that's a quick walkthrough of what we have in the platform, and I'm sure there'll be some questions we can take on that. But we'll switch gears and basis with SD-WAN and talk about specific TOSCA features we use in the context of SD-WAN. What are some of the different service models behind the scene that we created with SD-WAN, and then take on some use cases of with the abstraction of making it vendor agnostic, but also giving the option at runtime picking the VNF of choice for that security solution. I'll hand off to Patabi at this point to help us walk.
Yeah, thank you, Gaurav. So that was a good overview of our platform. Hello, everyone. My name is Patabi Ayaswamy. For the remainder of the session, I'll be going through some of the high-level TOSCA features, and followed by that, we'll also go through some of the sample TOSCA models that we have used in our use cases. And finally, we will go over the challenges that we face to address our use cases and deploying our services, etc. Back to the TOSCA features, we primarily use the TOSCA specification version 1.2. And of course, we have made some extensions to the specifications to suit our needs. And also, there are certain limitations and work on specification version 1.2. And we make use of the standard type definitions like the data types, node types, requirements, and capabilities to define our TOSCA models, and then also defined using those standard type definitions. we make use of the standard lifecycle operations offered by TOSCA. And as part of these lifecycle operations, we provide the implementations which would be invoked by the orchestrator. In addition to the standard lifecycle operation and custom interfaces to meet our use cases, for example, we have defined our own custom interface called upgrades that we make use of to upgrade our service instances whenever there are model version changes to our TOSCA models. And even though TOSCA specification supports an imperative workflows, that's something we are evaluating. But as of now, we primarily rely on the declarative workflows. And on the service topology, where we define our service input instances, etc. And at a high level, primarily the service inputs map to the properties of the nodes or the node properties, and the outputs map to the node properties as well as the attributes that are defined as part of the node type definitions. Mapping feature in certain use cases, for example, supporting a VNF use case, security VNF use case, where we make use of substitution mappings. And the node referencing feature, where you can reference properties in service or in a different service. So we make use of the node referencing feature. Just wanted to highlight, we also have some extensions similar to node referencing. We also implemented service referencing, which can reference services at a high level rather than going to the nodes that are. Finally, we package our TOSCA models as a Caesar with the directory structures as defined by the TOSCA specification. Next slide, please, Gaurav. And in addition to the standard type definitions that are offered by, we also use a combination of YANG, where the properties that are not participating in the orchestration capabilities, we model them as in YANG. And in TOSCA, we model those properties at because these properties don't participate in the orchestration. So this can be a pass-through from the orchestrator perspective. And we package those YANG schemas as well as the JSON schemas as part of the TOSCA model as an artifact. So that orchestrations, when the values are passed for these configuration properties, orchestrator can validate against a corresponding YANG schema or the JSON schema before it can be passed down to the implementation. So this is one of the critical. We don't natively model all the properties in TOSCA. Instead, we use a combination of TOSCA data types as well as the YANG data modeling for the configuration related properties. Next slide. So now we will go through some of the SD-WAN related TOSCA models that we use. And at a high level, let me just give you a high level one. So at a high level, SD-WAN is an overlay service that we offer that we configure on top of the underlay infrastructure. And Comcast offers physical as well as virtual CPE boxes that we provide to the customers, and we configure the SD-WANs on those physical CPEs or virtual CPEs. And these VCPEs or the CPEs, those are configured through a concept like a VNF manager. And so we work with a partner or vendor that offers this functionality. And these VNF managers provide a set of REST APIs using which our platform can push the SD-WAN configuration onto these CPE boxes. And these configurations are primarily, it's a two-step process where we push the configurations to the VNF managers, and afterwards we push the configuration from the VNF manager to the CPE boxes that are in the network. So it's a two-step process. And we model these SD-WANs through the set of 4 services. And these services are, in fact, of course, linked together through the service referencing or the node referencing that I mentioned earlier. And the underlying VNF manager, we also model that VNF manager as a node type within our TOSCA model. And we create a corresponding node instance for the VNF manager, which these services refer to, so that we infer the URL endpoints, the authentication credentials, etc. for the VNF managers through this node referencing or service referencing. Next slide, please. So this is a subscriber service we have, where subscribers actually refer to the actual customers, and we typically model the customer name, the type of the customer, etc. as part of our subscriber model. And then these customers are first need to be onboarded onto the VNF managers so that the subscriber specific information can be pushed to the CPE boxes. So we have this relationship where a customer is configured or managed by this particular VNF manager through the managed by relationship. And one VNF manager can manage one or more subscribers. So we have a limit. So there could be multiple subscribers that are managed by a single VNF manager. And once we exceed that limit, then we spend more VNF managers to manage these additional subscribers. Next slide. The next one is the UCP service. So this actually represents the physical or the virtual CPE boxes that we offer to our customers, where the SD-WAN is configured. And we primarily model the type of the UCPE box, and what is a software version or the firmware version running on the box, how many interfaces that are configured, that need to be configured on this box in terms of WAN interfaces, LAN interfaces, the bandwidth information, etc. And of course, this CPE has a relationship to the customer or who owns this CPE box, and which VNF manager manages this particular CPE. And these relationships are managed or defined in the TOSCA model in terms of the belongs to and the managed by relationships on the UCP model. Next slide. And the next service is the VPN service. The VPN service primarily represents the VPN service that is being offered, which is used by the various UCPEs to communicate with each other. So we primarily capture the VPN name, type of the VPN in terms of full mesh or hub and spoke, and what is a VPN ID, etc. So these informations are modeled as part of this VPN node type, and a subscriber or a customer typically can have one or more VPN services, and they can segregate their network as per the VPNs, so that they can configure which sites can talk to what other sites on the other side for a given VPN. And so this VPN service, so a customer can have one or more VPN services that can be applied onto the UCPE. Next slide, please. And finally, we have this VPN site service. So this pretty much covers all the SD-WAN specific features that can be configured on the UCPE, and in terms of the various features that we talk about or that we support, like the quality of service, the CGNAT in terms of the network address translations, then your DHCP server and relay configurations, then your routing configurations in terms of static routes, BGPs, etc. Then you have the internet connectivities and the firewall related configurations. So all those configurations are modeled as part of this VPN site service. And this VPN site service has relationship to the subscriber, for which subscriber or which customer this VPN is configured. UCP box, this VPN site configuration is applied. So those relationships are modeled through the TOSCA relationships. Next slide. So as we have seen, there are various configurations, feature configurations. We don't model all of them natively in the TOSCA data types. Instead, because these properties or these configurations are not orchestration related, so what we have done is we model those configurations in natively in the corresponding JSON schemas out of those YANG models, and these configurations are modeled as JSON data types in our TOSCA model. These are some of the features for which we have directly modeled in the YANG, like the interface configurations, routing related informations, DHCPs, CGNATs, firewalls. So pretty much majority of the configurations we model natively in YANG, and JSON data types in the TOSCA model, and then the orchestrator and the plugin implementations, we do the validations against the corresponding JSON schema. Next slide, please. So this is at so can you go back to the previous slide? Yeah, so far what we have seen is for the SD-WAN related, so we have like 4 services we have modeled, like a subscriber service, a VPN service, a UCP service, and a VPN site service, which are connected to each other through the service referencing or the node referencing features. All these configurations are applied onto the UCPE through the VNF manager, and which we also model as one of the node types within our TOSCA models. And in some scenarios, there are, when we talk about the firewalls or the security related, there are various vendors that offer more advanced security capabilities. So we give this flexibility to our end customers, where depending on the packages that our customers select, so we go with a set of vendors like vendor A, vendor security functionalities, where we onboard or offer security services through one of the third-party VNF vendors. And so probably in the next set of slides, we'll look at how we instantiate a firewall VNF over data models. Next slide, please. So in order to support multiple vendors on the security VNF, so we make use of the abstraction concepts offered by TOSCA. And of course, we do make use of this abstraction security side, where we, on the node type definition side, we use this concept of derivation, where you could define a base class where we model the common set of security functionalities, vendor-specific functionalities in the derived node types. And on the other side, we also make use of the substitution or the service decomposition that is offered by TOSCA, where we abstract out generic node. Then for different types of vendors, we have the vendor specific node types and the topology templates for those vendors. And then we make use of the substitution mapping to selectively pick a vendor based on the runtime input and do the service details. So this is an example of how we abstract out our firewall VNF, where this is a vendor agnostic abstract firewall node type, where we define the common set of properties that are applicable, and then we define the requirements and the capabilities, and provide the lifecycle operation that are supported as part of it. And we also define the vendor specific node types. Next slide, please. Yes. So in this case, so we define our abstract firewall node type, and at the same time, we also define the vendor specific firewall template that can substitute the abstract node types that we defined earlier. And we also map the requirements to the substituted service template. So during runtime, based on the runtime properties where we get what type of vendor to use or what type of features, based on it, we do this substitution so that the appropriate vendor firewall template is selected. Next slide. So this is another example where if you have multiple vendors like a vendor A and vendor B, and based on the inputs through the service decomposition, our orchestrator can pick up which vendor to make use of for the firewall service. So far, we looked at a couple of use cases where we went through SD-WAN as well as the security VNF, where in the security VNF, we make use of the substitution capabilities offered by TOSCA. And now we just want to go over some of the high-level part of our end-to-end service deployment management and monitoring of the services. Some of them are specific to TOSCA, but some of them are also general challenges that we have. And if you look at our SD-WAN based services and VNFs, so these are primarily software-centric, and some of these VNFs can be run on-premise, and these VNFs come with different types of domain-specific controllers, and these controllers offers different types of APIs, and the versioning of these controllers are some of the high-level challenges that we have to deal with so that the services can be deployed seamlessly onto our network and managed. Next slide, please. So in addition to those SDN specific challenges, so we also have orchestration related challenges where the network could be configured through our automation platform. At the same time, you could also configure some tools and CLIs and command lines, etc. So that causes challenges in terms of which is the source of truth, whether it's an automation platform or whether it's a network as a source of truth. And what happens when it's a multi-step process? What happens? Do you do an auto rollback, or how do you fix partial configurations, etc.? So those are some of the high-level challenges. Then, because for use cases, we have multiple services and on an ongoing basis, what is the impact to another service that depends on the service? Do you also go and update the other service? For example, you change LAN interfaces on a UCP service. What is the impact of, should I update the VPN site service that depends on this UCP? This dependencies is another challenge where we have to either automatically update the dependent services or have some layer push those changes in a proper way. And one of the biggest challenges that we have is how much to model and what not to model, because there are a lot onto the network, and it's a choice of how much of those configurations we want to model as part of TOSCA, and how much of those configurations we want to model outside of the data models and then have them as through templates or standards that we deal with in terms of what to model, and when we model, how much to model, to what level to model. And service upgrades is another challenge because we have to roll out newer features on an ongoing basis, where when new features are in, those new features in our TOSCA models, that means a newer version of TOSCA models needs to be deployed. That means we have to upgrade our existing services that are created using a specific model version. We have to upgrade all those services. So upgrading services takes a lot of time when we switch. So upgrading service does take time, and we have to plan for service upgrades with network impacting or non-network impacting, etc. So there are some certain challenges that we deal with as when it comes to service upgrades.
Yes,
Challenges.
thanks, Patabi. Yeah, I would like to stress upon and iterate like automation being the top of the list. Technically, it's a solvable problem, and as we know, the core of the orchestrator can do the comparison to what is out in the network, but essentially that is possible if you have very strong closed loop and detection and discovery happening. In a typical north-south architecture that we showed earlier, you want the flow to always happen from north to the south if devices or even directly on the target VNF platforms, there's always that risk of being out of sync, and that's what we are highlighting, and that's what results in having synchronization challenges. And you have to invest significantly in we have seen this not just in the platform, but also, as I mentioned, the orchestrator that could talk to many other orchestrator from different vendors. The VNF managers could essentially be an orchestrator as well. And in those scenarios, our platform acts as a master. Things where we have noticed with the vendors platform as well, if there's a backdoor change done directly on a device, there could be sync issues happening in their respective orchestrator. And of course, master orchestrator is going to be out of sync with that. So essentially, you want to stick to having that common interface is very key to maintain, and the backdoors need to be operations on backdoors need to be minimized or closed upon. The other part, source of truth. Even though when it comes to configuration is always in the network, so we had to decide in certain scenarios when it comes to configuration how much to model and when not to model. That's also a very key aspect where sometimes you have to make decisions that this is not something you're doing. And as we started on the journey of adopting TOSCA, as we said, many of our configurations are already driven off of YANG. So this paradigm of doing JSON-based schema and sort of TOSCA as the container to carry that. But essentially, the configurator need to have ability to read what's there in the network for the configurations. And in many of the scenarios, we did not decide to model each and every configuration in native TOSCA. And lastly, the service upgrades. Again, it's not the technical aspect, but how do you do zero downtime on your platforms when there are actual services being provisioned and activated by OSS system, and you want to do an upgrade? How do you solve those challenges that with zero downtime? I think that's the key part. We want to stress we grapple with and are solving. With that, that's all we had for this session from the slide. We can move on to Q&A, Dee and Jane.
Okay, that was great. Thank you so much. And we do have try and clump some of them together. I think and you touched on this a little bit, but sort of a series of questions are asking about security and functioning as security. How do you trigger the action after a change in the topology of the application in particular? And then he goes on to ask about the migration of cloud resources from one environment to the other. So those seem different to me, but if they don't seem different to you, again, along the same sort of path is use cases of security functioning being activated along with the orchestration. Does that make sense?
Yeah, I'll take on this second question of when resources, how do you reorchestrate those? So essentially, that's where what we mentioned in our architecture. You need to have a discovery, and you need to have an event response capability in the platform. And essentially, when those detected, you will trigger certain policies through the event response and essentially go back and do a replan of the service within the orchestrator. And that's where the closed loop helps in catching on where there are shifts happening in the network, and you sort of replan and reconcile, or you recourse correct what is in the network. Yeah, and I think the first question was, how does a security use case is initiated, if I get the question right. Essentially, there is a...
Yeah, go ahead, so that I'll add on to your...
Yeah, go ahead and you can take the first question of how these security services are initiated.
Sure. So I'll give it a shot, and then you feel free to chime in, Gaurav. So when it comes to our security, we deal with it in multiple aspects. So to begin with, we focus on our initial day zero configuration kind of thing. So we make use of the cloud init functionality, where we have the initial standardized configuration that needs to be applied, using which we bring up the VNF, and using the if the VNF is running on a cloud, so we make use of the cloud to bring up the VNF instance in the appropriate cloud using those cloud images. And then we push the standard configuration, the day zero configuration, as part of the bootstrapping of that VNF. We push that in the VNF is up and running. Then we have other systems where we take care of the licensing aspects, and for the ongoing firewall rules related management. So depending on the vendor, either we provide an SSO access direct to the vendor management application, using which we can configure firewall rules on an ongoing basis using the vendor portal itself. And for the common set of use cases, we use our modify standard firewall rules across the various VNFs through our platform.
Okay, great, thank you. So again, we've got some questions. If we don't get to your question, don't worry, we will afterwards. I'm just looking at this question about what is the best orchestrator for OASIS TOSCA? That might be a Chris question, but in your experience,
well, every vendor has their, if these are not open sourced, I think every vendor would have there as the best. So it's not for me to judge
right,
which one is the best. I mean, from a vendor perspective,
right. Okay, so we've got some more here. Let's see, could you explain why an orchestrator extension was used instead of a TOSCA feature for service referencing?
Yeah, so yeah, I can take that question. So the referencing, where from a given service, you can reference a specific node that is defined, that is part of some other service, right? And then you can specify a filter to specifically select that particular node instance, and then get some properties. Thought what we had was similar to this abstraction concept. We felt there is no need for a service to know about what are the nodes that are defined as part of another service. Instead, we just provide this only the service and not about the nodes that are defined within that service. So that's why we went with an extension in terms of, rather than doing a node referencing, we're peeking into someone else's services node, rather this another service can expose all the output in that service as an abstracted interface kind of thing, so that a service defines a set of inputs and a set of outputs that that is available to be consumed by the other services, and a service referencing only can have access to the service outputs that are defined in the extension to primarily to have this service encapsulation. There is nothing wrong with doing the node referencing. We support both. In fact, we support both service referencing as well as node referencing, depending on the use case.
So just for a second, just back to the best orchestrator. This person wants to know specifically which orchestrator do you use?
It's a vendor proprietary one that we have.
Okay. Okay, good enough. So on this feature with the firewall example, it appears that you're aiming the JSON schema supported. I think what they're saying here is you're assuming that the supported JSON schema is uniform across all vendors. Is that
this
a correct
similar
assumption?
question came up in the last webinar also run by Chris, where yes, when it comes to substitution, there are some high-level assumptions in terms of the inputs that is fed in as part of the common set of inputs for your vendor supported service templates also. So yes, so there is an implicit assumption that it is the common set of inputs.
Okay, terrific. And then along the same play, how do you support plug and play? Okay.
Theoretically, yes, but of course, it's not something that you just exercise as plug and play directly in your production environment. But essentially, one of the goals of allowing other vendors to come in and participate with their DNFs and complying to the models that we have. And essentially, the focus should really be on, once we have designed the service models or the specific services such as security, and participate in this ecosystem and build their respective implementations to comply with. And essentially, the plugin is where the business logic would reside in order to orchestrate against the target VNFs, which are going to be managed by the vendor. Either in their managers that we are running in our distributed data centers. So from that aspect, the architecture supports plug and play, where you build business logic and not have to, and once the interfaces are already available, the models are available in the catalog at runtime. Based on the inputs, you can do the substitution and pick the right workflow that's going to get executed and invoke that plugin. I think if I got your question, that's what I see as plug and play, where you could bring in more vendors into the ecosystem and essentially beef up on your catalog.
Fantastic. Well, we're getting close. So Gaurav and Patabi, thank you so much. What I'd like to do is, for the remaining few minutes, turn it over to Chris, just to tell you a little bit about where we're up to on the technical committee. Thank you guys, that was really great. And again, we'll follow up with an email with the recorded version. Thank you.
Yeah, thank you.
Thank you.
I want to second that. Thanks, Gaurav and Patabi. This was very exciting. And it's especially exciting to see scaled deployments in production for what is for Comcast a business critical application, and to see TOSCA being used not just for the initial deployments, for service updates, for dynamically responding to changes in the network. So those are all use cases that are absolutely envisioned by TOSCA, and we'd love to get real life feedback to help drive evolution of the language. As you know, and it's these kinds of experiences based on real world deployments that could help make the standard even better than it already is today. So we'd love to get more feedback and more interaction so we can help move that standard forward, both in terms of extensions to the language things you're doing, but also in terms of best practices, how things that are not necessarily reflected in the language, but might be adopted by the community as the best ways of doing certain things. So we'd love to keep the communication channel going and get that feedback reflected both into the language specification, but also in guidelines to the community. So again, thank you very much, and we'd love to keep interacting. As it relates, I'm sorry, go ahead.
Yeah, certainly, I think likewise, as you know, there are still challenges, for us to solve, and we would like to help in addressing those as well.
Excellent. Love to get that communication growing so that we can get more people involved and get those extensions into the community. As far as the webinar series, we have one more session scheduled for, this one is for June 30th, and we will hear a presentation about some more novel use cases around functions as a service, specifically functions compute platforms, and distributing those to the edge and using TOSCA as the mechanism to enable those. And again, that presentation is on June 30th, and hopefully that'll illustrate even more the breadth of application domains that can be supported by take a break in the summer to accommodate summer vacations, and then we'll revisit in the fall with a focus on TOSCA version 2.0 and additional stories if there's significant interest from the community in presenting. I appreciate everyone's interest in TOSCA, and please keep checking our YouTube channel, keep checking the TOSCA website for updates to the standard, and we look forward to interacting further next month and later this fall. So thanks everyone for joining, and we'll see you next.